Hello, this is Vedat from Programmership. In this chapter, we are gonna talk about generics. Sometimes in our app, we need to use different kinds of types and expect the same result. So what do I mean by this? Suppose you have two variables. Let's say var my first value is equal to 10, and let's add another one, my second value is equal to, let's say, 20. And you want to swap their values with each other. Then my first value will have 20 and my second value will have 10. So how to achieve this? Of course, we can create a function that can swap two variables. So let's do that. Let's say func swap values, and we'll need two parameters. First variable that will be integer, and second variable that will also be integer. But our parameters need to be in-out parameter. In-out. I already explained in-out parameters in the function chapter. You can take a look at that. Remember, using an in-out parameter, we can have the variable reference address instead of copy of its value. With that address, we can manipulate the variable directly, so the variable will be affected by any changes. So let's try to swap the values inside the function. Let's say let's temp. It will keep the first variable value for swapping, let's say first variable, and here in the next line, the first variable value will be second variable value, and finally, the second variable will be our temp constant. So let's print the variable values first and then use our function. Let's say print before swapping my first value is equal to my first value, and my second value is my second value variable. And in the next line, we will try to swap our variables. To use in-out parameter, we have to pass our target variable referenced address. To do that, just put an ampersand symbol before the variable name. In this case, the first parameter is my first value, and the second parameter is my second value. So after the swapping operation, let's copy the same print statement and paste it at the next line. So hit run, and we can see before the swapping, my first value is 10 and my second value is 20, and after the swap operation, my first value has 20 and my second value has 10. That means values were swapped. Well, here the variables are an integer type. What if I want to swap two double variable values instead of these integer variables? If we try to use our swap values function, it will give an error because our function was created for integer variables. And remember, Swift is type-safe language. We need to be aware of that. Well, you can say that creating another function for double variables can handle our needs. You are right. But what if I need some string variables to be swapped as well? Creating another function for string too? No man, it's not the right way. In this case, generic types come into play. With generic types, we can create an alias for a type and say to Swift compiler, hey bro, we'll specify this type later. Just trust me. And guess what? Compiler trusts you. It will look at the type definition at runtime when we define it. So let's change our swap values function into generic function. To do that, we will put angle brackets after the function name and put a type alias that will represent our generic type. Let's say T. Generally, we represent generic types with a single letter such as T. Of course, you can use longer words. Here, instead of integer definition, we just use our generic type, which is T. Let's say T and T. Let's try to run it and see if it is still working. Hit run. And it works. So what happened here? When we call the swap value function, the first parameter's type will define our generic type. And in this case, our T will be integer. Why? Because my first value is integer. So let me change the variable type. Let's say 10.5. And for my second value, let's say 20.5. And these are double now. Hit run. and it still works. Let's make them string. Let's say hello for my first value and world for my second value, and hit run again. It is also working. We can see that generic types can be useful. Please pay attention. Here inside the swap values function, we defined the parameters type as t, which is the same generic type. That means we cannot pass variables which have different types. Otherwise, it will give an error. Alright, we can also define multiple generic types in the swap values function. Just add your new generic type with comma, let's say p and v. Or you can use x, y, z. It's up to you. But of course, our swap values function will not work now because function parameters have different generic types. So we cannot swap it. Anyway, I think you have got the idea about multiple generic types definition. We can use these generic types within the function. Well, I want to make another example. But first, let me delete all of this. Suppose we have an integer array and we want to get its maximum value. Let's create an integer array. My numbers is equal to, and let's put some values, 50, 30, let's say 40, and let's say 25, 73, and 60, and finally, let's say 15. We can create a function or get the maximum value of this my numbers array. Let's create a normal function. Let's say func get max value, and let's say from targets array, that will be an integer array, and it will return back an integer value, which is the maximum value. And inside, I want to create a temporary variable, which is temp max, and it will be equal to the first value of our target array. Say 0, which is the first item of target array. And in the next line, let's create a for in loop and loop through each target array's item. Let's say for index in, it will start from 1 because we already get the first value into temp max, and it will go through the target array dot count. Here inside the for in loop, let's check if the target array's current item is greater than our temp max, then get this item into temp max target array index, just like that. And at the outside of the for in loop, just return the temp max. Here outside of the get max value, let's call the function and see if it is working. Let's say print get max value, and our parameter is my numbers integer array. Let's hit print, and it returned 73, which is the biggest value in our array. It works. So in this case, if I want to get the maximum value of a double array, it will give an error because we created get max value function for integer array, not for double. You may say that, come on bro, let's use generic type for that function as well. Are you sure? Well, let's try to use generic type and see if it works. Let's put our angle bracket and say t for the type, let's say t, and return type also t, and hit run. It gives an error because inside the function we used some comparison and tried to get the maximum value, right? If it is generic type, then we may not be able to use this comparison. Suppose you try to pass a Boolean array and try to get its maximum value. What will happen then? It doesn't fit with this function, right? We cannot get the maximum value of a Boolean, so we cannot use generic types like that. Well, what can we do here? We have to convince the Swift compiler that our generic type will be used only for an array with comparable type, not for any other types. There must be a way for that. Of course there is. There are type constraints that are used for restriction. Type constraints. You can search it for detailed information. We can use comparable type constraints in our case. This is actually a protocol. We can conform our generic type to that protocol for preventing incomparable type definition. Let's use it. Just put a colon at the end of your generic type and then define your type constraint, which is comparable. With that type constraint, we can only use an array with comparable types. Let me hit run. And it works. So let's make some values of my numbers double. let's say 20.6 for that, and for this, let's say 73.4, and hit run. We can see it still works. We can also pass a string array to that function, but it doesn't make sense because our function will work correctly for numeric arrays. There are different kinds of type constraints. I'm gonna leave that to you. We can also use generic types inside a class, structure, or enum as well. Let me create a simple structure that can store an array. But first, let's delete all of this. And here, I'm gonna create a struct called my storage, and it will be generic. Say T again. Inside the struct, I want to create a private property which is called item, and that will be an array of T type. And at the beginning, we can define it as empty. We use the same angle bracket definition for generic type. Inside the structure, we define an empty array in generic type. When we create an instance of my storage, we need to specify its type explicitly. So let's do that. Let's say var my array is equal to my storage. This time we need to specify the type, let's say integer. And that's it. This is the most basic definition of our storage structure. Let's add some features. I'm gonna add a function that we can add value into our storage and also return the last value. Let's say func append. Our value will be t, which is our generic type. And inside the append function, we can say self.item.append the new value. But of course, because struct is value type and we try to change its property, we have to use mutating keyword for that function. So let's add another function that will return the last value of our item array. And the return type will be t. And let's make it optional because there may not be any value to return. Here inside the getLastValue function, let's say if self.item.count is greater than 0, then return self.item.last, else just return nil. Well, let's try to add some value into my array and try to get the last value. Say my array dot append, say 5, and I'm gonna copy this line and paste it a few times, say 15 and 25. In the next line, I'm gonna print the my array dot get last value. Let's hit print, and it gives the last value, which is 25. We can use exclamation mark to unwrap the optional value. Let's hit print again, and we can see 25, which is the last value of my array. We can also add a computed property that controls if the storage is empty. Let's add one. Say var is empty, that will be boolean type, and it will return back the self.item.isEmpty. So here, let's try to print the isEmpty property. Hit run. It says false. Why? Because we already added some values into my array. If I delete these lines and hit print again, we can see it returns true. So it works. Well, let's add a pop feature that can return the last value of the storage before deleting it. Inside the my storage structure, let's say func pop value, it will return the generic type and it will be optional. Inside the pop value, let's control if the self.item.count is greater than 0. Then we can return the self.item.removeLast, which returns the last value of an array and then remove it. If item count is equal to 0, which is else, then return nil. And of course, this function also needs to be mutating. Here outside the structure, let's try to append some value again inside the my array. Let's say 5. I'm gonna copy this line again and paste it. Let's say 55 and 75. And here inside the print statement, I will call the pop value. Let me print. Here it returns the last value of my array. if I copy this line and paste it again and try to run it again, in the first print, it will return back the last value, which is 75, and then remove it. So now in the next print statement, our last value will be 55, and it will print 55, then delete it. We can also loop through each item to print them. So instead of these print statements, let's say while my array dot is empty is not true, then print my array dot pop value, and let's hit run. And this while loop goes through each item of my array until it is empty, then print each item. So it works. Alright, that's it for this chapter. I hope you have learned something about generic types in this video. See you in the next one. Goodbye.